Hello everyone, we are from Group 2 and we're going to present about thermal conductivity of fluids. So fluids can either be liquid or gas. In this experiment, the liquid we're going to use is acetone and the gas is air. So the first part of the experiment is we're going to calibrate the thermal conductivity of study units. In this experiment, we're going to determine the incidental heat transfer, or mainly known as heat loss. By determining the heat loss, we can also find the thermal conductivity of these two fluids in the next experiment. So the first part of this experiment is we're going to make sure that the water flows in the system. So in order to make sure the water flows in the system, we have to make sure that the valve, which is in the red color, to be on and to be flowing. So the LPM needed in this experiment is 5 LPM, and in order for us to make sure that only 5 LPM flows in this pipe or in this tube, we can either use this measuring cylinder, as we don't have the sensors. So this is the measuring cylinder, and by determining the amount of liquid in this measuring cylinder to be filled in the time given, we can determine the flow rate. So once we already set the flow rate for the water, we need to make sure that the power supply is on, which is at the back. And before we starting the experiment, I need to explain about the water. Why do we need this water system is because we need to regulate the temperature inside and to avoid from the machine breakdown. So to begin with the experiment, we can start switching on the main switch here, and we need to wait for a while for it to be switched on. And once we got the readings being displayed, we can start with our first experiment. In order for us to start, we need to make sure before the switch is switched on, the power regulator is at the minimum, which is 0. As you can see, the 0 is displayed there. And then we can on the heater switch, and next we're gonna set the power regulator to 5 watts. It takes some time. So once we already set to 5 watts, we can get the reading for these two properties needed, which both talks about temperature after 10 minutes. Remember, 10 minutes interval. So the first temperature is the inner cylinder temperature, or as you can see, it's actually the average of inner cylinder temperature. And the second one is the outer cylinder's temperature. Or it's the same, it's the average of the outer cylinder temperature. So once we already find out the temperature for both inner and outer cylinder, we can go to the next reading, which we have to increase it by 10. And next we're gonna repeat the same experiment for 10, 15, 20 and 25. This is to make sure that a best fit graph can be created and the thermal conductivity can be calibrated. So moving on to the next experiment. So once we are done with this experiment, we have to make sure that the power regulator is set to 0 back and the heater switch is being turned off. So for the next experiment, we are just gonna use air as our medium, and we need to determine the thermal conductivity of air. So in order to do that, we need to wait for the power indicator to turn to 0 and be regulated back to 0. And once it's being regulated back to 0, we can start the experiment by straight away setting it up to 25 watts. This is for air. I repeat, this is for air. So once we already set the power resistor to 25, we can switch on the heater and we can wait till it hits 25. And then the next step is to take both the reading for inner cylinder and outer cylinder, 1 or 2. one symbolizes inner cylinder and 2 symbolizes outer cylinder. So this experiments also we need 10 minutes, and in between the 2 experiments before we need 5 minutes interval. Okay, before taking the reading we need to wait 10 minutes, just remember, so that the temperature indicator is constant. So once we are already done with this experiment, just turn it back to 0 and switch off the heater switch. Okay, now we're going to move on to acetone. So as everyone can see, in order for us to use the acetone, we need to wear proper gloves, which can be found there. There's gloves, and once we already use the gloves, we can obtain few amounts of acetone in a small beaker, and we need the syringe as well. So the first step, we have to make sure that both the valves is closed, and we are going to enter the syringe here, the down part. Okay, once you already enter it nicely and tight, we need to on or allow the valve, the liquid to flow through the valve. So the next step is, imagine if there's acetone here, you can just press it and make sure that it's flowing up. And to determine whether the acetone is already filled up in this small container, we have to notice it from the top whether it's spilling out or not. So once it starts spilling a little bit, we can stop flowing in the acetone. And before removing the acetone which is being filled up, we have to close the valve first to avoid spillage. So just close both the valves and remove the acetone. Okay, once done, make sure that it's being done clean and neatly and no spill of acetone, because you might danger yourself. And the next step is, now is acetone being filled, we can straight away move on to get the readings of inner cylinder and outer cylinder. Our first step is switching on the heater switch and straight away set the power regulator to 100, which is around this part of it. Okay, once done setting the power regulator, we can wait for another 10 minutes. You must wait for another 10 minutes, and we can get the reading for the average inner cylinder and also outer cylinder as the previous experiments. So this is the last part of the experiment, which is determining the acetones. And before ending up this experiment, what we have to make sure is the acetone is being drained. The acetone is being drained. To make sure, to allow the acetone to be drained, we have to fix the tube back and allow the valve to be open again, and we have to suck it out by pulling the syringe. So once the acetone is being drained and being removed, can be said that the experiment is being done, and graph can be tabulated, and the thermal conductivity of both acetone and egg can be determined. Thank you.